Welcome to Solved Maths. No theory, just solutions. Let's break the fraction. We start with the fraction 3 over x plus 1 times x minus 1. Can we split this into smaller parts? Now, multiply both sides x plus 1 times x minus 1. Let's find a and b by choosing smart x values. First, let x equal 1. Next, let x equal -1. Now we put a and b back into the equation. We start with x over x minus 4 times x minus 1. Can we split this into two easier fractions? Now let's multiply both sides by x minus 4 and x minus 1. Let's find the values of a and b by picking smart numbers for x. First, let x be 1. Next, let x be 4. Now put the numbers we found for a and b back into the equation. We start with x minus 1 over x plus 2 times x minus 2. Can we split this into two simpler fractions? Now multiply both sides by x plus 2 and x minus 2 to remove the denominators. We will find a and b by choosing smart values for x. First, let x be 2. Next, let x be -2. Now plug the values for a and b back into the equation. We start with 2 over open bracket 2x minus 1 close bracket times open bracket x minus 2. Close bracket. Can we write this as two smaller fractions? We multiply both sides by the denominators to get rid of the fractions. We will find a and b by picking smart values for x. First, let x be 2. That makes a go away, and we can solve for b. Now let x be 1/2. That makes b go away, and we can solve for a. Now we plug the numbers for a and b back into the equation. We start with x plus 3 over x times x plus 1. Can we write this as two smaller fractions? Let's get rid of the denominators by multiplying both sides by x times x plus 1. Now we will pick smart values for x to find a and b easily. First, let x be 0. That makes b go away, and we can solve for a. Now, let x be -1. That makes a go away, and we can solve for b. Now we plug in the values of a and b to get the final answer. We start with 2x minus 1 over x plus 1 times 3x plus 2. Can we write this as two smaller fractions with a and b? Let's remove the bottom by multiplying both sides by the denominator. Now we will pick smart x values that make terms disappear, so we can solve for a and b. First, let x be -1. That makes b disappear, and we can solve for a. Now, let x be -2/3. That makes a disappear, and we can solve for b. Now we plug a and b into the equation. We did it! We start with 3x over x minus 1 times x minus 2 times x minus 3. Can we write this as 3 smaller fractions with a, b, and c? We multiply both sides by the denominator to remove the fractions. Let's pick x values that make terms disappear. This helps us find a, b, and c. First, let x be 1. That makes b and c disappear. We solve for a. Now let x be 2. That makes a and c disappear. We solve for b. Now let x be 3. That makes a and b disappear. We solve for c. Now we plug in a, b, and c. We've split the fraction. We start with x squared minus 2x plus 4 over 2x times x minus 3 times x plus 1. We want to split this into 3 simpler fractions using a, b, and c. We multiply both sides by the full denominator to get rid of the fractions. Next, we expand the right side and compare like terms. Let's solve it step by step. First, let x be 0. That helps us find a. Now let x be 3. That helps us find b. Now let x be negative 1. That helps us find c. We're done. This is the final split form of the original fraction. We start with 2x minus 1 over the product of 3x minus 1 and 2x plus 1. We write it as the sum of 2 fractions with a and b. Multiply both sides by the denominator to get rid of the fractions. Let's choose x values that make solving easier. Let x be 1/3. That helps us find a. Now let x be negative 1/2. That helps us find b. We're done. Here is the final split version of the original fraction. We start with 5x minus x squared over x times x minus 1 times 2x plus 1. We break it into 3 parts, 1 over x, 1 over x minus 1, and 1 over 2x plus 1. Now multiply both sides by the bottom part to get rid of the fractions. Let's choose x values that make the letters a, b, and c easier to find. Start with x equals 0. That helps us find a. Now x equals 1. That gives us b. And now x is negative 1/2. That gives us c. Here is the final answer with a, b, and c filled in.